Today's lesson is about the properties of exponents, or also known as powers. Pretty sure you've seen this before. Exponents and powers mean the same thing. Today we're going to learn how to, we'll learn some rules, about 5 or 6 of them, and then we're going to see how to use those rules to simplify exponential expressions. Before that, let's define exponential expressions or powers, and then see, learn the different rules that apply to them and see how to use them to simplify. So let's define those. Okay, so when you have a number, for example, some number b, and you have a power here, this is what we call an exponential expression. An exponential expression, simply because we have an expression, we call this number, the bottom number, we call it the base. And the top here, of course, is called the exponent or the power. They mean the same thing. Okay, so these numbers b and p are real numbers. That means they can be any sort of numbers. It could be negative, positive, it could be decimals, could be fractions. So any form, these can take any form. Call them real numbers. And we know what real numbers are. We'll learn that in the first lecture. That's basically all the types of numbers that you can come across, excluding the complex numbers. So real numbers include whole numbers, natural, rational, irrational, and so on. So start with a simple example here. So when you have the expression here, that's an exponential expression. This is the exponent, this is the power. Say 2 to the third power. Okay, so this is 2 to the third power. So what this means is basically 2 is raised to the third power. And what do you do to find the value of this exponential expression?
Multiply.
Multiply 3 times.
That's right. We're going to multiply the base by itself 3 times because the power is 3. So we do 2 times 2 times 2. Once you expand it, this is the expanded form of this exponential expression. Then you evaluate these 2 at a time. So this is, you can say these 2 multiply to 4, then times by the third one, and again multiply, you get 8. So this is the exponential expression. This is what we call the expanded form. Okay, and finally, this is the value that you get by multiplying these. Okay, so all these numbers are pretty much the same. So this to the third is the same as 8, is the same as 2 times 2 times 2, just written in different forms. So basically exponents are just an easier way of writing multiplications. So imagine if you have the power 10, for example, here. You don't want to write 2 times 2 10 times. Instead, this is a shorter version of it. It means it's the same value. So we prefer that over the longer expanded version. Here's another example, 3 to the 4th power. So 3 is raised to the 4th power. So again, to evaluate this, it's not 3 times 4. That's, some people make this mistake often. It's not 12. It's actually, what is the expanded form again of this exponential expression?
3 times 3 times 3 times 3.
That's right, 3 times 3 times 3, 4 times. 1, 2, 3, 4, because the power is 4. Then when you evaluate, so this is the exponent form. When you evaluate it, you want to do this 2 at a time. You don't have to do all at the same time, so just do these 2 first. 9.
How to multiply 9 and 9, yeah.
That's right. Finally, you get 81. So 3 to the 4th is basically just 81. The value of it, this is expanded form. Okay, so we're going to look at another example. So like I said, sometimes the base and the power, they're not always whole number or natural numbers. They could be negatives here or negatives here in the power. Could be fractions, decimals. So let's see a case where we have maybe negative. Let me write that again. So sometimes you may have negative powers. Okay, so when you have negative power, we need to deal with that. We need to fix that accordingly. So you have negative 3 to the second, or something like this, negative 3 to the second in parentheses.
By negative power, you don't mean that the power is negative. You mean that the base is a negative.
Exactly. Thank you. So I mean, base is negative. We're going to do negative powers later. That's right. This should be negative bases or negative base. Okay, so these two expressions here, are they the same? Are these equal to the same thing?
Yes.
What are they equal to?
Minus 3 times minus 3.
Okay, that should be for this one. So here's the deal here. The parentheses actually make a difference. Parentheses here make a difference. These are not the same. Their values are different. So the base here, the power here is 2, the base is 3. This negative is not part of the base because it's not like this one. It doesn't have parentheses. So this negative is not part of the base, it's by itself. We write it down first, and then we expand this 3 to the second power. So 3 to the second is 3 times 3. Again, this negative is independent of the base. We multiply this, we get negative 9. But in this expression, we have the power, which is 2. What's the base of this power?
Minus 3.
That's right. So this whole thing is the base. Because of the parentheses define the base. So when we expand this, we're going to repeat the base twice. So we're going to repeat negative 3.
For the first ones, can you write minus parentheses 3 times 3?
So this one here, just write that minus first and expand this. Okay?
Yeah, but could you say minus and then parentheses 3 times 3?
You may use that. You may do that, yeah. For the second one here, as you can see, so this is the base. So that's why we wrote negative 3 and negative 3. If you have more, if the power is higher, then you have more of these. And this, when you times negative 3 by negative 3, what do you get?
Positive 9.
9.
That's right, positive 9. You can see the values are completely different, even though they may look the same. So keep in mind, if you have parentheses, whatever is under the parentheses is the base. If you don't have the parentheses, only what's directly under the power is the base. So the base here is 3, not negative, because negative is by itself. You write it first. Think of it as a negative 1 if you want. Also, you can think of it as a negative 1 here. So it's negative 1 times 3 to the second. You write that negative 1 here first. You multiply these. Negative 1 times 9 is negative 9. Okay, so this one case when the when you have a negative with a power, so you need to understand whether that belongs to the base or not based on the parentheses. Let's do a couple more examples. So what is negative 5 to the second? And what's negative 5 to the second? What is this one equal to?
Minus 5 times
minus
5.
5.
That's right. So since we have parentheses, we can say negative 5 times negative 5. We repeat this because that's the base. And this, of course, is positive 25. What about this one?
Minus 5 times 5.
It's a negative, and then we say 5 times 5. So negative, you bring the negative over, you expand this, 5 to the second is 5 times 5. Again, that negative will always be there. And you multiply the two, you get negative 25. So these are not the same. Sometimes the power can be higher. It's not always 2. For example, you may have negative 1 to the third. And which is not the same as this. You may get the same result, but the way we do that, the way we expand them is not the same. So to expand this, so negative 1 is the base to the third. So we're going to write negative 1 with the parentheses because that's the base 3 times. Then you expand or you simplify 2 at a time. So we're going to do these two first. Negative 1 times negative 1, which is positive 1. Okay, so this is positive 1 times negative 1. This turns into negative 1. For the second one, it's a little bit different. Is the negative part of the base?
No.
It's not. So you're just going to write that negative because there are no parentheses. Bring that negative over. Let's expand 1 to the third, which is 1 times 1 times 1. Again, the negative will always be there. 1 times 1 times 1 is 1. Okay, we may, sometimes it really depends on the power. So you may get the same result, but the method is different. So this is the expansion of both. Okay, so keep that in mind. Now let's look at negative powers. What happened here? So see how to, the case of a negative power. Negative power or exponent. Okay, so we saw the base here. Now we're going to do power. Like I said, it's not always something like this. So say 2, or rather, okay, for example, 2 to the third is not the same as 2 to the power negative 3. These are completely different numbers. We know that this one is, we did that earlier, so 2 times 2 times 2 is 8. What do you think this is equal to? Negative 3, or negative 2 to the power negative 3.
Minus 2 times minus 2 times minus 2.
No, that minus is not here. It's not part of the base. It's next to the power. So it's a little different. So 2 to the power negative 3. Anybody else want to try? Okay, so here's how you handle these negative powers.
Is it with the division maybe?
Okay, what do you mean exactly by that?
That instead of multiplying, you divide 2 divided by 2 divided by 2.
2 divided by 2, not exactly, but so this is what we do. First, you can turn your exponential expression into a fraction. Just put 1 under the exponent. Then what you want to do is want to move this down. If you move this down, it turns into a positive power. Okay, because this one had the negative power. To make it positive, you move it to the other side of the fraction, and it turns into 2 to the power positive 3. Okay, so this one moves up. Now, what's 2 to the third power?
8.
That's right. It's the same as this. 2 to the third is 8. So when you see 2 to the power negative 3, you know it's going to be not 8. If this was positive, this would be 8, like this. But if you have a negative, instead of saying 8, you flip it. You say 1 over 8. So you can do this right away. You don't have to go through these 2 steps. Okay, so instead of, ignore this for a moment. So 2 to the third is 8. 2 to the third is 8, but instead of saying 8, we're going to say 1 over 8 because of this negative, because this flips that value when we do turn it into a fraction. You can do this in one step. You don't have to go, like I said, through these steps. Let's say, for example, we know what 5 to the second is. 5 to the second is 5 times 5,
25.
which is 25. But what's 5 to the power negative 2 in one step?
1/5. No, 1/25. Sorry.
1, that's right, 1 over 25. That's the difference the minus makes. So instead of saying 25, just flip it, say 1 over whatever that might be. Another example quickly. So what is
Is the bottom of the fraction called denominator?
the bottom? It's called the denominator. Yeah. Okay, so what is 3 to the power negative 2 in one step? Everybody?
1/9.
1.
That's right. 1 over 9 or
1 over 9.
Okay, so that's what happens when you see a negative power. Simply make it positive by moving it to the other side. You may also have, let's say, 1 over 1 over to the power negative, for example, 4 to the power negative 2. Same thing here. When you see a negative power, you want to move it to the other side. What happens to the power if you move it to the other side? What happens to the negative power if you move it to the other side of the fraction?
Turns positive.
That's right. So 4 to the second. Okay, this power turns positive over 1. And of course, what's 4 to the second?
16.
That's right, 16. Okay, so whether the power is up or down, just move it to the other side of the fraction, then simplify it. You could also have, let's say, 2 to the power negative 3 over maybe 5 to the power negative 3. Both of these have negative powers. So what do you think happens here?
Is that a 2 or a 5 at the bottom?
Say again?
What is that at the bottom? 5 to negative 2 or?
That's right, yeah, 5 to negative 2. So we have 2 negative powers here. What do you think happens to these now?
5 to.
What do you do to these?
You change them. 5 to the 2 or 5 to the second.
That's right. So this one is negative. It's going to move down. This one is also negative, moves up. So we kind of flip it here. So it becomes 5 to the second over 2 to the third. Once you make the powers positive, you can simplify. 5 to the second is 25, and 2 to the third is 8. As simple as that, okay? So remember, when you see this in the homework, just make them positive.
Just flip it.
And
if it's a fraction, make it into a fraction. Okay.
I'm sorry, repeat that.
No. I'm just saying, just if there is no fraction, then you basically turn it into a fraction.
That's right. If it's not a fraction, you can always put 1 and the number, it turns into a fraction.
Professor, I have a question.
Mhm.
If is a negative, the power always is going to be a fraction?
Not always. You can see here.
Only in this case.
Yeah, it depends. It all depends. Just turn it positive. May end up fraction like this, like the first one here, or may not. Okay, so it depends on the power and which one is negative. There's another example here. So let's say you have 2 to the second over, let's say, 3 to the power -2. So what do you think happens here?
2 to the seconds times 3 to the second.
Exactly. So this one happens to be negative.
Mr. Abdullah,
Yes.
we have to flip also, yeah, here. Like we did.
Only flip or move the one that's negative.
So both
This
is gonna be 1.
Yeah, so this one is positive here. So we don't need to move it down. It stays where it is, stays up. But this
When
one
its power is positive, yeah?
That's right. So this one, because the power is positive, this one has a negative power, so it needs to be up. So we're going to move that up with a multiplication, okay? It's going to move up, turns into 3 to the second. Then you do both, so that's 4 times 9, which is 36. Okay, make sure again, only move both if they're both negative. If one is positive, one is negative, only move the negative one. That's basically the whole idea with negative powers. Whenever you have a negative power, you move it to the other side of the fraction, where either up or down, it turns positive. Once it turns positive, then you can expand it, simplify it, and do whatever you want with it. Okay, so makes sense, everybody? Any questions?
Yeah, to understand.
Is everybody okay? Okay, let's do another thing. So what happens when you have...
Breaking up, Professor.
I'm sorry?
Couldn't hear the last.
We just can't hear you.
I asked
Seconds, I
you
guess.
guys. Ask you guys if you had any questions about this before.
Your audio was breaking
Your
up.
microphone was breaking up.
Oh, okay. Is
Yes,
it back?
still.
Is it back now?
Uh-oh.
Is it good now?
Sure, you're cutting.
We cannot hear you, Professor.
All right. I think I'm back now. Can you guys hear me?
Yes.
Yes.
All right. I believe I got disconnected.
Yes.
Okay, so we're talking about, so now after the negative powers,
Repeat that last one we just did. Just go through it again. When we come up to 36, just go through it again.
I'm sorry, what was that again? Can't hear you.
Repeat that last one we just did. Yeah.
Okay, this one here, so basically we just moved to this one up. This stayed here because it's positive, stayed here. We moved this one up, it turned positive. Then we simplify, 2 to the second is 4, 3 to the second is 9, that's 36. Now let's see what, the power can be 0 sometimes. For example, 5 to the power 0. What do you think that's equal to? It's not 0 before you say it. What is 5 to the power 0? Or any number, any real number to the power 0 for that matter?
5?
No,
Equal to 1.
that's
I
right.
think the 0.
5 to the power 0 is 1.
5?
I thought it equal to 1.
That's right. To the power 0 is 1, yeah. So any
Isn't it every power that it's raised to the 0 equals 1?
real number, yeah. Any real
So 1
number,
times 5 is 5.
a real number to the power 0 is 1.
Professor, your mic
You're
audio
cutting off.
is really coming in and out. Hear you properly.
It's still breaking up, right? Okay.
Yes.
Let me, yeah, I'm having,
That sounds better.
my internet is acting up right now. Not sure exactly why.
It's not you. I had to increase my internet the other day too, because it kept kicking me out and all types of craziness.
Okay.
So you might have
Usually I have a high-speed internet.
everybody's on.
Yeah, for some reason it slows down sometimes. All right, so let's get going here. So 5 to the power 0 is 1. Same thing, any number to the power 0 is always 1. Any number. But there is a trick here. 5 to the power 0 is 1. What about negative 5 to the power 0? What about negative 1?
Negative 1.
That's right, negative 1. Because again, this is not part of the base. You write it down. This is 1. 5 to the power 0 is 1. We're writing 1. Very good. What about x? Any real number to the power 0 will be, any real number x could be negative, a positive, could be decimal, fraction. Anything to the power 0 again is 1, right?
1.
What if we had negative x to the power 0?
1.
Say it again.
Minus 1.
That's right. So negative first, because it's not out of the base. Then x to the power 0 is 1. What about negative x in parentheses to the power 0?
1.
That would be 1. Whatever the base might be, that's...
Teacher, if you're saying something, we can't hear you. No.
okay.
Teacher, we can't hear you.
1.
I can hear you. Can you guys hear me, the rest of the class?
We have to guess if you're saying something or not when you pause.
Same thing here. You guys, I can hear your voices breaking up. Let's see here. Can you guys reply back if you hear me? Everybody? Can you see something back?
Right now, yes.
Yes.
Everyone?
Yes, now I can hear you.
Yes.
Yes.
Yes, we can hear
But
you.
I guess it comes and goes.
What I find in another class that I take, if everybody turns off their video except the instructor, that makes it go a little bit better. So maybe.
Okay. I was gonna say that actually. Guys, if you can turn off your videos, I believe that's one of the reasons, yeah. Thank you. I was actually gonna say that in the beginning, that takes the bandwidth, the videos, high definition. All right, so like I said, negative 5 to the power 0 is, the negative stays here, 5 to the power 0 is 1, x to the power 0 is 1. Then here we have a negative, stays here, x to the power 0 is 1. For the last one, we have parentheses, whatever is inside the parentheses, when raised to the power 0 is 1. So those are basically some of the trickiest things about the powers, the negative bases, the powers, and zeros. Now let's move on to some rules. I'm gonna, pretty much all these, we learned a couple of rules here and some more. We're gonna write a list of all of them. So let's do number 2 here. I'm gonna call this rules. Rules or properties of exponent. All right, so first one we're going to look at is for any real number x again. Call it 1. For any real number x, let's say you have 2 to the third, and you multiply that by another real number to another power. Okay, some real number to a power 2 times same real number to another power.
You multiply the exponents.
Not exactly. We do not multiply.
As an exponent.
Exactly, we add them. Even though this is a multiplication, but the powers add up. So 2 plus 3 is x to the 5th. Okay, these powers, again, could be negative, could be positive, whatever they are, just combine them and see what the result is. For example, you may have a negative 1 times x to the 5th. Okay, so what do you do with that?
So would you say when two values are multiplying, you add up the exponent?
That's right. That's right. We combine them. We combine whatever their signs are. For example, here we have -1.
But it has to have the same variable.
Yeah, it has to have the same base, that's right. Okay, so -1, combine that with +5. This turns into,
4.
that's right, +4. Just combine the powers, whatever the signs might be. You may even have two negatives, for example, this. Okay, x to the power -2 times x to the power -3. What is this equal to?
-5.
-5.
Exactly. So we combine these, combine them. Could be addition or subtraction depending on the signs of the powers. And this is, of course, x to the power -5. And as always, we want to turn this power positive. We don't want negative powers. Always turn your final answer into something with a positive power. So what do you do again to make this power positive?
You
Be
put it
1
down.
over x to the 5th.
That's right. First you turn it into a fraction if it's not a fraction. And then just move it down. So this moves down, the power becomes positive, +5. You don't have to write the plus, but I just wanted to explicitly show you what happens when you move it down. So this. Okay, so whenever you do something, make sure if your power doesn't end up positive, you want to make it positive simply by moving it to the other side. If it's down, again, you move it up and vice versa. So that's one of the rules of one of the properties of exponents. Let me write those rules somewhere on the side here. I'm going to summarize these as we go. So the first one, so for any real number, x to a power a times some real number to the power b, what is this equal to in general?
X, A plus B.
Exactly. So that's a summary of this. A and b could be negative or positive. Whatever the case might be, you just combine them. Number two, now, instead of multiplying, we're going to have a division. Let's say 5 and 3. Instead of multiplication, we have a division here, x to the 5th over x to the 3rd. What do you think happens here to this, to the powers? So the base will be x.
Subtract.
That's right, we subtract the powers. So with division, subtract 5 minus 3. Not the other way around. Always this one minus this, so 5 minus 3. Which is x to the 2nd power. And just like these powers also can be negative or positive. So this, let's see what happens if you have, let's say 4. Okay, x to the 4th over x to the 7th. Okay, it's going to be x to what power? 4 minus 7, which is?
-3.
That's right, -3. And again, you want to make this positive, so it would be 1 over
X to the 3rd.
x to the 3rd. That's right, you just move this one down, becomes positive. Okay, so it's always going to be in this order, this minus this, not the other way. So the top minus the bottom.
Denominator minus the denominator?
The power in the numerator minus the power in the denominator. Top minus bottom.
Oh, what's the name of the, what's it called, the top part?
Numerator. Numerator. Okay?
So hold on, I have a question. Not, you know, but we had a problem before. We had, you know, negative exponents, and then we had to take one exponent from the bottom and put it to the top when it was fractions. But now, and so obviously that was like division, but now we're still dividing, even though we don't have a negative exponent, so there's nothing to move up or down. But now we're subtracting. Like, when do you know how to use which rule? I mean, I know that when it's a negative exponent, you're going to either move it from the top or the bottom. But in terms of this addition or in terms of the subtraction part, like it's a little weird.
Okay, so if you have a division and you have the same base, so this, we want to simplify this into one expression. We have two expressions here. We want to put that into one expression. So to do that, you keep the base.
Have to be the same. So it couldn't be like a 2 and a 5. It would have to be a 2 and a 2. Is that what you mean?
That's right. The base has to be the same. So all these rules that we're going to do here, the 6 or 5 of them, the base must be the same. Same for here, x and x. If it's x and y, you couldn't do this.
Okay, that's important to know.
Okay.
Right.
So let's do another case here. Put in some negative powers maybe. And so for example, 6 and x to the power negative 2. So now there's a couple of things we can do this, couple of ways. Back to what we were doing earlier. So this one has a positive power, this one has a negative power. So
you can do the multiplication.
That's right. We can move this one up because it's negative. We can move it up. Or if you want, you can subtract right away. But be careful with subtraction. It should be 6 minus 2. Okay. There's always a minus for the fraction, but there's another minus here because this happens to be negative. So it's going to be 6 minus 2. That sounds confusing. So I suggest you first turn this positive. Once you have all positive powers, it's easier to handle. So only this one moves up. This one stays here. So it's going to be x is 6 and x to the power 2. So move this up, turns into a multiplication. And now, what do you do with the powers in this case?
You add them.
That's right. Now it turns into something like this.
Okay.
You add the 2, so it'll be x 8. Okay, so try to make your powers positive when divided. We turn them into positive powers, it becomes easier. Unless you're multiplying here, so you don't have to make this one positive. If you're multiplying, we know we just combine these. We combine them, you get a positive power. Same thing here. You don't have to flip them. Since you have a multiplication, combine them first. And after that, if you end up with a negative power, you turn it positive. But either way should lead you to the same result. You can do it either way you want, that's fine. Now let's write this other rule here, second one.
Professor, if the result is negative, we always have to put in positive?
That's right, always turn it positive if it's negative.
Okay.
All right, so let's write this rule down. So in general, for any real number x to a power a over x to the power b, what is this equal to?
X
X
minus
A minus B.
A minus B. Mhm.
That's right, x minus b in general. And depending on the signs, you do the appropriate operation. Number 3, let's go over number 2, let's go on over to number 3. I'm sorry?
Go back up a little, rule number 2, just go up a little bit so I can catch it.
Go up like this?
No, down.
No, she wants to see the
Okay.
rule thing
All
on
right.
your side.
All right, so let's do number 3. We have another rule. This one is also pretty simple. Let's say you have 2 or x to the power 2 and another power 3. It's possible to have this, even a third power. So whatever is inside is also raised to the power, third power. So what do we do with the power?
X 2 times 3.
That's right. In this case, 2x 2 times 3. In this case, we times the 2 powers. Okay, do not confuse that with this one. Here we have 2 bases. We add the 2 powers. Here we have only one base, 2 powers. If you have 2 powers or more, just times them. So we get x to the 6. and again, these could be any signs, could be negative, could be positive. Let's say.
So how could you word this when like a variable has an exponent to an exponent?
Mm-hmm. So we have 2 powers, x to the second to the third. Okay, so we just times the exponents. Another problem here. What is this equal to?
To be x minus 1
Mhm.
multiplied on 5.
That's right. We times the 2, we get negative 5. But again, this one is negative. We need to make it positive. So we move it down, turns it to x to the power 5. Okay, x to the power 5. What about the case where the 2, let's say both of them are negative? So x to the power negative 3 to the power negative 6. What is that?
X18.
That's right, x to the power 18. Negative times a negative is a positive. So no need to flip this. This we needed to flip because it turned to positive. This one is also positive. Okay, so remember, if you see power over power, you simply multiply them and you get 1 power. So let's call this number 3. So again, in general,
A to the B.
that's right, for any real number x to the power a to another power b, the result is x to the power,
Of A times B.
that's right, a times b, or we can just say ab. So you have a plus b, a minus b. ab means a times b. So you don't have to write the multiplication or the parentheses. You can just say ab, which means a times b, not plus b. Okay, almost there. Maybe a couple more rules.
You go back up to the rules so I could copy it, please. Thanks.
Let's do one more. So the rest of them, basically we already saw. Just gonna pretty much rewrite them. There's another one. It's possible to have something like this, x to the power a and y to the power a. So when I have two bases, the powers are the same, not the bases. So x and y, x times y to the power a, we can put these two together into one expression instead of two.
XY to the A.
That's right. Since they both have the same power here, we can put them together in parentheses. Again, the parentheses define what the base is. And we can just basically put the a on top because they both share that a. So we can split them like this, or we can put them together. We're going to see later why we need to do this. Sometimes we need to go this way or that way, but it can be useful. Another example of this is if you have, let's say, if you have, for example, A, B, actually let me use A, X, Y, Z instead. You may have X, Y, Z all to a power A, for example. So all these share the same power. We can split all these, we can distribute the A over all of them. Instead of writing them together, we can split them. What do you get if you split them?
X to the power of A, Y to the power of A, Z to the
X, A.
Exactly. And write each one separately.
And Z to the A.
That's right. So the parentheses, again, they mean this whole thing is the base. So the A belongs to all of them, not just one of them. It belongs to all of them. But it will be different if we didn't have the parentheses. If we didn't have the parentheses like this. We had something like this. A belongs to, does it belong to all of them or what?
No, only to the Z.
Exactly. So this means the power belongs to this only. These are separate. You write them first, then you evaluate whatever this is. But in this case, with the parentheses, we define what the base is. So that's another rule, number 4. Let's write that down here too. Let's say 4. And so again, in general, if you have, let's say x, y to the power a, we can write this as, this turns into what?
X to the A, Y to the A.
A times Y to the A.
That's right. And again, this is useful. We're going to see later how to use that to simplify some expressions. Number 5. The number 5 is basically, we already saw it, just rewrite it. So when you have x to the power, let's say, negative a, what is this equal to?
1 over xa.
That's right. If you want to put it over a fraction first, then you move it down to make it positive. X to the power a. So that's another rule. You saw it earlier. Let's write it down with these. So x to the power negative a is simply x to the power x. 1 over power x to the power a. Number 6.
Oh, no.
So these are, we already saw, we just rewriting them. Number 6, what if you have a fraction like this? And the whole thing is raised to the power negative a. Power. So basically this belongs to both of them. And imagine if this was x to the power negative a, and you give that power to this one as well, y to the power negative a, right? So we distribute it to both
Y
of them.
to the power of a above x to the power of a.
That's right. So now we have two negative powers. If you flip them, if you move this one down, this one up, this turns into y to the power a. Power negative moves up. This power is negative moves down, becomes x to the power a. Which is basically the same as, now we could put them together because they both have a. You could say y over x to the power a. In other words, how do you get from here to here in one step?
Just flip
You just
everything
flip them.
without, yeah.
Exactly. You just flip it and the power turns positive. As simple as that. So, but make sure the negative is for the entire fraction, not for just one number or one, as we saw earlier. It has to be, for example, here, we didn't flip it because the negative is only for this one, not for this one. So this stays here. But this works only if you have parentheses. The entire fraction is raised to a negative power. So let's write that down here. So 6. So for any real numbers, x and y, all to the power negative a. What is this in one step? This will be
Y. How do you express that in words when you have y over x?
and just like that, y over x.
Oh, okay.
A to the power,
Of a.
that's right, a to the power a or positive a. What else? So we saw that, we saw this. Another one we saw earlier also is, let's call this, that is number 6, number 7. I believe that's the last one. So it's the one we saw with the 0. So for any real number x to the power 0, that would be
1.
1. And negative x to the power 0.
Minus 1.
That's right, negative 1. So the negative stays here. But if you have parentheses, anything inside the parentheses, whatever the sign might be to the power 0 is
Still 1.
1. Okay, so you can add those 3 here. Number 7. So x to the power 0 is 1. Negative x to the power 0 is negative 1. Negative x to the power 0 is also 1. That's pretty much all your rules here together. And these are very useful in this class. We're going to be using them.
Go back to the rules, Professor. Number 7, the whole thing. The rules, right?
Here we go. So these again are very important. They're basically the backbone of algebra, because algebra involves letters and numbers, and those letters or variables, they have powers. So 1, 2, 3, negative, whatever it might be. So it's very, very important that we understand these rules. I would say pretty much maybe 80% of this class is based on this. So once you understand them, they make life a lot easier. And we're going to be using them whether directly like this or indirectly with topics such as factoring or solving quadratic equations or dealing with polynomials. Okay, so they're not hard. Okay, they just need to know exactly what operation to do and when. And we're going to be doing a lot of these. We're going to practice a lot of these next class. And more practice with some expressions with more variables, 2 or 3 variables and different powers. We're going to see more complex expressions, and we're going to see how to simplify them using those rules. Okay, does this make sense to everybody? Any confusions, any questions about any of this?
No.
Okay, everybody else, you guys okay?
The way you teach it, make it easier for me to understand compared to before.
Well, thank you for that. And again, you guys can always rewatch this stuff. Unfortunately, the last lecture wasn't recorded. I thought I was recording, but I wasn't.